We will do. Hello everyone, so now we are going to do the host root. So in this scenario what we will do, we will write the IP root and here we will give the complete IP, because we are saying host root means if you have here one server and you have another server, if your manager told only this server should be accessible, this server will not, no one can access the other server. How we can do? We have many different methods. We can do with ACL also. We can configure access control list and do that one. But now we need to do with the host root. So what we will do? Just now we discussed the static root. If you remember, we discussed the IP root and we will write the network ID and the subnet mask of the destination network ID, destination subnet mask, and next hop. So this is a next hop and this is a, imagine this one is a 192.168.2.3. so this complete IP we need to give with the complete subnet mask. Then this will when we configure this way, that is known as host root, means only we can access only this host. If you see theory what I wrote here, it is where destination address is specified a device IP with a subnet mask /32 if we are using IP address IPv4. If we are using IPv6 then /128, means we need to put complete subnet mask, means all will be 255. In simple words, we need to mention complete IP. Whenever any packets are coming, they can compare complete IP. If the complete IP is visible, then only they can access this one. If complete IP is not there, they cannot access. Before we are keeping this as a 0, as a static root or network root, means this will make, we will make this as a 0. But now we need to keep same thing here, whatever the complete IP. So only that server is accessible, other server should not accessible. A host root is used to route the traffic to specify host, only particular that host, not all hosts. Anyhow, we will do one lab, so you will have the idea. We can do this anywhere, but anyhow let's do this also in the packet tracer, so it is easy for what we can say, connecting the host easily we can connect. So what I will do, I will take two router, one router here, one router here, and I will take two switch, one switch here and one switch here. Let me make little big here, little zoom in this one, okay, and I will make this two router here and one switch here, and I will take, imagine I will take one PC here, one PC here, and I will take two server here, one server there and one server here. Okay, so now we can give the name. Example I will give, this is a R1 and this is a R2, this is a R2 and this is a switch 2 and this is a switch 1, and this is a server SRV1 and this is a SRV2, server 2. Okay, so now let me give the connection. This is between two router and this is from here, this is from here, this one, and then this to connect to the server, this connect to this from here, this from here. And we can write the IP schema. I will write here IP schema. We will give here 192.168.12.0/24 and here 192.168.1.1/24 and here also 192.168.2.1/24. okay, this is the IP schema, and the IP we will put here 192.168.1.2, same as we done before. So let me assign here the IP to the desktop here, and the gateway will be 1.1, and same thing here, here also 1.3 I will configure here, and the gateway what we are saying 1.1 here. Okay, this is the two PC, two machines, and this is a switch 1 and this is R1 R2, and here we can give the IP also here. For this router what IP we can give, 192 dot, let me write here, we will give this IP 192.168.2.2 for this server. I will paste this in, I will assign the IP to this server. This is the server we will assign, and the default gateway will be 2.1. okay, and here also I will assign IP here 192.168.2.3, and let me assign the IP inside the server. So this is the server, we will go inside and we will assign here 2.1 here. Okay, so this way we assign the IP. Let me show you. This is our scenario. Okay, this is our scenario. And your manager asks you to configure the host root for this server. So only this server is accessible, this server is not accessible. So how we can do? So let me take notepad. Here I will give the name as a host root. Okay, host root we will give the name, and we will do the R1 configuration. Enable config t host name R1, and the interface we have fast Ethernet 0x1. I will give IP address 192.168.1.1 255.255.255.0. then we will write no shut, and then other interface. Let me copy and paste this one here, and if you see, let me, the other interface is 0x0. So this is 0x0, this is 12.1. okay, so this way. Okay, finish. And now I will copy this same thing, and I will divide the page for the R2. I will paste R2 here. This will be the R2 here, this will be the R2 here. R2 is having F0x0 is 12.2. This is 12.2, and 0x1 will be 192.168.2.1. so this is 2.1. so this way we assign the IP address. Now we need to configure the root. If you see this here, what we are saying, it is where destination address is specify device IP with the subnet of 32/32 if we are using the IPv4. If we are using IPv6, then /28. means we need to write the complete IP address of the device of the server, and we need to write complete 255.255.255.255 4 times. Okay, so here if you see this one, right, host root. So what we will do, we will write here, let me open the GNS, this one, the packet tracer, and here I will write IP root, same thing as we do before. Now we need to write the complete IP of the server. This server need to accessible. Okay, so we need to write complete IP. We will write 192. Let me check, someone write something. Specify the host ID /32. Yeah, we need to specify the host ID with the /32. Yes. So what we will do now, we will write here 192.168.2.2. then we give space 255.255.255.255 4 times, and then next hop IP. Who is next hop? We are doing here, so next hop will be 12.2. okay, so we will write here next hop is 192.168.12.2. okay, any doubts? No doubts, right? Let me repeat again. When we are configuring the host root, we need to write the IP root and the complete IP of the host and the /32. That means whatever the IP of the server, we need to write complete IP by /32. /32 means 255.255 4 times we need to write. So I wrote. After that, at last we need to write the next hop. Next hop means the router which is opposite to us here, to go to that route, this router, this interface 12.2. so this one we done, but we need to do the reverse routing also. If we are sending anything from here, if we are sending ping, that need to come back also, right? This need to come back again. If we did not do the reverse routing, it will not come back. Let me show you. What I will do, I will paste this configuration. Okay, I will copy this configuration. Let me copy and paste this configuration. This is a R1, right? from here to here is, this is a R1 configuration. I will copy and I will paste here in the R1. I will write here no, and then we will paste this configuration. Everything is good here, no issue, nothing. If you want to check, we can check also. We will write show IP root and show IP interface brief. So we have the interface is done because we did not configure the other router. So let me copy the other router configuration and we will paste this one from here to here. I will paste this here in this one. I will write no here and then I will paste the configuration here. If you see here, no error, nothing. Here also everything is good. If we want to check, we can write here show IP root and show IP interface brief. So this interface too, and everything is good, up. I will save this configuration, and if you see here in this router, now we will have the root also, host root, show IP root. We are getting the host root. If you see, this is the host root. We are getting complete IP with the /32. Okay, so this one is available here. If we ping, it will not work. Example, I will make this PC to communicate with this server. Okay, this PC is having IP or not, we will check IP config. If I write IP config, our machine is having the IP here. Okay, this is our machine IP 192.168.1.2 and this is our machine default gateway. So now I will ask ping 192.168.2.2. okay, 2.2. if you see what we will have, because it is having request timeout. Okay, a request timeout, it is showing here because we don't have the reverse routing. Packets are going from here, but reply is not coming because we don't have reverse routing here. Let me check if debug command is work here. Debug IP ICMP. I debug this one just to check if any traffic is coming in this router or not. Okay, I enable debug. Let me send the traffic again here. I will send the traffic and I will check here. If you see, yes, see here, when I am pinging from here, traffic is coming. Okay, but this router don't know the destination, that's why he is unable to send. What he is saying, our machine IP is 192.168.1.2, our computer IP. He is saying he want to send the request, okay, from 192.168.2.2. he want to send to this, but he don't know about this address, where it belongs to this address, because we did not done the reverse routing. Again, let me repeat what I want to say. What I done, I tell this router, if anyone want to go to this IP, forward the traffic to this IP here, this one. I told to this router, with /32 I told. So only this server is accessible. Okay, I done forward routing, but we need to do the reverse routing also. So reply will come back. If we did not configure the reverse routing, it will not come back. So I did not configure the reverse routing. Only I configure the forward routing. But I want to check when I am sending the traffic, that traffic is reaching here or not. So what I am doing here, I am sending the traffic. Okay, I will write here minus, I think minus T, or here in the packet tracer we can write here dash T space. So continuously he will ping. Okay, continuously he will ping. So I am generating the traffic. from the PC 192.168.1.2. Okay, and I am checking here in my router, in the R2 router. So R2 router receive the traffic and he want to reply to that one, because this guy is replying. He sent the request, it is coming to this server is replying, but this router is dropping the traffic. Router is saying, I don't know, this is the destination, and this server is replying, but I don't know this one, destination, unhost, unreachable. That's why traffic is drop here. And here if we see, we are getting here request timeout, but we are receiving the traffic. How I check? I write here debug IP ICMP, but don't do this in the production network. Your CPU will go high in the router if you do in the production network. So for lab purpose you can do this one. For lab purpose you can do that one, but in the real scenario don't do. So with this one we are saying, okay, our router, this router is receiving the traffic, but he is unable to forward the traffic because he don't have the reverse routing. So now we can do the reverse routing. How we can do the reverse routing? We will go in the global configuration mode. We will write IP root, and we need to define the network. Which network? 192.168. Or let me disable this one. Okay, let me disable. What I need to disable? Debug. I will write UAll. With UAll we will disable the debug. Now I will go here. I will write IP root 192.168.1.0.255.255.255.0, and then what is the, I am saying to router, if anyone want to go to this network, I am not doing the host route, I am doing the static route, that is a network route. I am giving complete network network. So network ID I give here, because reverse is you can give network ID, but forward route you should give only the host route. So network ID, if you get all this traffic for this network, forward that to this IP 192.168.12.1. So I will write here 192.168.12.1. 192.168.12.1. Okay. So when we write this one, reply will start. I done the reverse routing. This is a reverse routing. This is a reverse routing. What I can do now, let me paste this configuration here in the R2, and now I will check here. Reply is start. Okay, reply before, reply is not coming, but now it started because we done the reverse routing. So in this one what we learn two things. First thing is, whenever we want to configure the host route, we need to define the host complete IP with /32. And whenever you are doing the forward routing, you need to do the reverse routing also. If we did not done the reverse routing, this router don't know about this network and he will drop the traffic here. So we done the reverse routing, so this router is forwarding that one. If you want to check, we can check again. Now it will show it is forwarding that one. Okay, let me save the configuration. I will write debug IP ICMP, and now if we generate the traffic, let's see, we are generating the traffic. Yeah, here generating the traffic. So he will forward. He is not showing. Let me check the debug IP events or ICMP repo routing packets. Let's see packets. Yeah, so this is the packets they are forwarding. It is showing that now it is forwarding. Okay, these packets they are forwarding. Before it is not forwarding. Now he is forwarding all. But don't do this in the production network. Now I will do UAll. UAll means it will disable the debug. So I will write save here, and now let me save the configuration here also. Okay, so let me stop this.